Hey everyone, today I'll be going over an easy Leetcode problem, 804, unique Morse code words. So very simply, as I always do, I kind of skip the description. I just go to a test case and explain what they want in my own words. The problem's linked in the description, so you can just read it yourself. They give you a list of words along with a Morse code mapping, which they provide. And we basically want to count the unique Morse code representations. Now you might think this would be 4, like, oh, these should all be unique Morse codes, but it's not actually the case. Sometimes they overlap, and the same Morse code representation can be 2 different words. So the very first thing we want to do is they provide this, so let's just call this our mapping, basically, and this is going to be a string array, and let's call this mapping, and this is going to be new string, like such. So basically all we're doing is just taking the mapping they provided us and making an array out of it. So we have our mapping, and basically, so this would mean A maps to this first one, B maps to the second one, so forth and so forth. So to actually convert a character to its Morse code representation, we actually just want to index it. So if we want A to map to 0 and B to map to 1, all we have to do is just subtract 97. By the character, and that's because A is actually ASCII 97, so you'll see what we're doing. So basically the next thing we want to do is have some set. Now the set is going to be a string, and we're going to call this set, and this is going to be a new hash set, and all we want to do is just return the size of that set at the end. So why do we want to do this? We want the unique Morse code representations, and sets maintain uniqueness. So basically, we're going to fill up this set with the Morse code representations, and the size of it will be the unique number of Morse code representations, because sets maintain uniqueness. So let's go through the words. So every word in words, and let's convert it to its Morse code representation. So to do that, let's have a little string builder, and I'm going to call this a current Morse. New string builder, and basically we want to go through each character in that word. So what did I say? So we want to fill up this with its mapping. So for each character, we actually want to shift it by 97, and that'll get us the index for this mapping. So basically we want to add to the Morse code mapping this character minus 97, so the mapping of this character minus, or we could just simply go minus A here. And the reason why we can do this is because if we actually look over here, it only consists of lowercase English letters. So basically we could just shift it by lowercase a, and that's going to get us the appropriate mapping in here. So let's do that, and that's going to get us exactly what we need for this. And then once we're done, the string builder will have the Morse code representation of this entire word because we've gone through every character. So let's simply just add current Morse to string. We have to do toString because right now it's a string builder. And let's run this. And you'll see we get 2 here. And let's submit this. And 63%. So I hope this made sense. Let's talk about time and space complexity. Space, worst case is actually ON, and the reason being is because for where n is the number of words, it's actually like we're going to fill up this entire set with every single word, or at least it's bound to the size of the words. So we are using extra space because we're using this set. Time is also just ON overall. Now you might think, oh, we're going each character through each word, but I'm really saying n, where n is the number of words. So really space and time is O of n. If you really wanted to be picky, you could go number of words times the most amount of characters in each word, but really this is the space and time. So yeah, I hope this helped, and I hope this made sense. Thank you for watching.